This chapter is on exponents and exponential functions, and the first lesson of the chapter is 8.1, applying exponent properties involving products. You should be on page 489. Notice what happens when you multiply two powers that have the same base. Now, I'm going to underline same base. You notice we're multiplying two powers that have the same base, a squared times a cubed. Now, a squared, remember, means we have two factors of a, and a cubed means we have three factors of a, and you notice if we write these out, we really have five factors of a, which means we have a to the fifth. A squared times a to the third is a to the fifth. Now, you notice if we just had added the exponents, we could have avoided writing this whole thing out. A squared times a cubed would be a to the fifth. This example above suggests the following property of exponents, which is known as the product of powers property, and I would get that in your notes. And here is the product of powers property. To multiply powers having the same base, you actually add the exponents, like I did here. When I see a multiplication of two bases that are the same, like I have here, I add the exponents and I'll immediately get to the correct answer. Okay? Here would be a sample of that, like 5 to the 6th power times 5 to the 3rd power. Do you notice I have the same base? If I add the exponents, I would get the correct answer. 5 to the 6th times 5 to the 3rd should give me 5 to the 9th power. All right? Let's try a few down here. You notice on this first sample, 3 squared times 3 to the 7th. I have the same base, so this is an example of the product of powers property. I have to add the exponents. 2 and 7 added up is 9. This would equal 3 to the 9th power. Or in the second example, this is 5 to the 1st power times 5 to the 9th power. I have the same base 5, and 1 and 9 added up is 10. This would be 5 to the 10th power. Or here, negative 7 to the 2nd power times negative 7 to the 1st power. I have the same base, negative 7, and if I add my exponents, I have 3rd power. And in question 4, x to the 2nd times x to the 6th times x to the 1st. I have the same base, x. Since I'm multiplying, I can add my exponents. I should get x to the 9th power. So these are all examples of the product of powers property. I'm multiplying with the same base, and I just add those powers. The second type of exponent property we're going to learn today is called power of a power. Notice what happens when you raise a power to a power, like here. A squared to the 3rd power. Now, doesn't 3rd power mean 3 factors? So look what they write. 1, 2, 3 factors of a squared. A squared means a times a. So here's my first factor of a squared, a times a. Here's my second, and here's my third. Do you notice I really have 6 factors of a? The answer to a squared to the 3rd power would be a to the 6th. You can see the 6 factors of a. Now, what would be the shortcut to doing this? Because I don't want to have to write this out on every problem. Do you notice if you take 2 times 3, you would have got 6? Okay? This example suggests the following property of exponents known as the power of a power property. And again, I would get this in my notes, power of a power property. In words, to find the power of a power, you multiply your exponents. Now you notice that's different than product of powers. In product of powers, we added, when it's a power to a power, we multiply. For example, 3 to the 4th power squared would be the equivalent of 3 to the 8th power because 4 times 2 is 8. let's try a few again. You can see I have a power to a power. This would be 4 to the 14th power because 2 times 7 is 14. Here I have power to a power. This would be negative 2 to the 20th power. Here I have power to a power. That would be n to the 18th power. 3 times 6 is 18. And here I have m plus 1 for my base. 5 times 4, power to a power. That'd be 20th power. Okay? So all of these would be an example of the power of a power property. Let's talk about the third and final property we're going to look at in this lesson. It's called the power of a product. Notice what happens when you raise a product to a power. Now remember, the word product means multiplication. Do you notice we have a multiplication raised to the third power? We have a times b raised to the third power. So look at what happens when I take a times b and I raise it to the third power. I have 1, 2, 3 factors of ab. Now, instead of writing it in this way, I could break this up. This is a times b, this is a times b, and this is a times b. I could group all the a's together first and all the b's after it. Can you see how I have 3 factors of a, which is a to the third power, and I have 3 factors of b, which is b to the third power. ab to the third power, so this would equal a to the third, b to the third. Now, how can I get from here all the way to here without doing all this work? The above example suggests the following property of exponents known as the power of a product property. Okay, and again, I'd get this in my notes. To find the power of a product, find the power of each factor and multiply. Okay? So for example, you can see at the bottom here, we have 23 times 17. There's a product raised to the 5th power. This statement in yellow is saying I need to apply the 5th power to the 23 and I have to apply it to the 17. Now, each year I have people look at that and think of it as distributing. You are not distributing. You are just applying the 5th power to each factor. So I got to apply the 5th power to the 23 and I have to apply it to the 17, but that's not distributing. Distributing is when you are multiplying a number that is being, like here, 5 times the binomial m plus 1, I would multiply 5 and m, and I'd multiply 5 and 1, and I'd have 5m plus 5. That's distributing. I'm not multiplying 5 times 23. I'm raising 23 to the 5th power, and I'm raising 17 to the 5th power. This is not distributing. Okay? Let's actually look at that in some samples. Like here, I have product to a power. I have to apply the 8th power to the 24 and the 13. Here, in the next example, I have to apply the 2nd power to the 9. I have to apply the 2nd power to the x, and I have to apply the 2nd power to the y, so I have 81x squared y squared. In this example, I have to apply the 2nd power to negative 4, and I also have to apply it to z. Negative 4 squared 16, and z squared. I have 16z squared. And in my final example, I have to apply the 2nd power to the 4, and I have to apply it to the z. I do not apply it to the negative in front because the negative is not inside the parentheses. So I have a negative out front, I have 4 squared and z squared, and I'd have negative 16z squared. Okay? Now, today, in the homework, they will have you use all 3 properties, and they will denote that by just using the word simplify. So when they want you to just simplify, that means they want you to group this together and make it and simplify this into a one-term expression, I guess is the best way to say it, okay? So when you look at this problem, 2x cubed, in parentheses, squared times x to the fourth, okay? Here's the first thing. Do you notice I have the power of a product? I have to apply the second power to the 2, which you see here, and I also have to apply it to the x cubed. So let's do that. 2 squared is 4. X cubed squared. This is the power of a power. We got to multiply for this. 3 times 2 is 6. And then I still have that x to the fourth at the end that I haven't touched. I'm just moving that down. Now here, do you see how I have the same base and I'm multiplying? Okay? So in that case, that's the product of powers. And in this case, remember, we add the exponents. So I would have 4x to the 10th power. So this whole statement, which I'm going to highlight in yellow, will simplify down to what I have here in orange, 4x to the 10th power. Let's talk about the term order of magnitude. It's very simple. Order of magnitude of a quantity can be defined as the power of 10 nearest the quantity. So that might sound a little complicated. It's very easy. First of all, power of 10 means the following. Okay, when they say power of 10, here are the powers of 10. 10 to the first, which would be 10, or 100, which is 10 to the second, or 1,000, which is 10 to the third, or 10,000, which is 10 to the fourth, and so on. That's what power of 10 means. This first sentence is just another way of saying that we are doing a quick base 10 estimate. All right? Keep on reading this. For instance, there are about 91,000 species of insects in the United States. The power of 10 closest to 91,000, okay, let me highlight that, 91,000. Which of these is closest to 91,000? I hope you're looking here and saying, well, 100,000 would be the closest. So the order of magnitude of insects in the United States, or species in the United States, would be 100,000, or 10 to the fifth. So you notice they wrote that here. There are 10 to the fifth species of insects in the United States. Order of magnitude is simply taking your number and rounding it to the closest base 10. They will have you do real-world examples with order of magnitude. For example, here, in 2013, the U.S. Department of Agriculture collected data on about 10 to the third honeybee colonies. So that'd be 1,000, 10 to the third. Next, there are about 10 to the fourth bees in an average colony during honey production season. 10 to the fourth is about 10,000. How many bees were in the USDA study? Now, sometimes these problems can be complicated because the numbers are so big we have a hard time picturing them. In that case, sometimes it's better to use easy numbers to make this easier to think about. So let's get rid of 10 to the third and 10 to the fourth for a minute. Let's just do this. Let's just pretend, we're pretending right now, that we had 3 honeybee colonies. And in each colony, there were, instead of that, there were 8 bees. So if I had 3 colonies, 1, 2, 3, and I had 8 bees in each one, what would I do to figure out how many bees there were? Well, I would take 3 times 8. I have 3 colonies, 8 bees. The answer would be 3 times 8, right? Well, now that I know I got to multiply, I can go back and do this problem normal, okay? I didn't have 3 colonies and 8 bees. I had 10 to the third colonies, which I'll highlight here, and I'm multiplying by how many bees we had in each one, which was 10 to the fourth. And remember, here is the product of powers, which means I have to add the exponents. The correct answer to this problem would be the USDA figured out that we had 10 to the 7th honeybees in the USDA study. Now, 10 to the 7th, remember, that would be the number. It's about 10 million bees. Okay, so we are using order of magnitude to estimate how many bees were in the study. Okay, let's try a few here. Let's simplify the expression. So here in number 9, you notice we have the power of a product. We must apply the second power to each factor. So number 9 would work out to 42 squared times 12 squared. I just simplified it. Number 10, I have the power of a product again. I got to take -3 and square it, and I got to take 9 and square it. I got to apply the second power to each factor. -3 squared is 9, and n squared is n squared. Number 10 would work out to 9n squared. Here, again, I have the power of a product. I got to apply the fourth power to the 9. I got to apply the fourth power to m cubed, and I have to apply the fourth power to n. I'm going to use my calculator real quick, and I'm going to apply the fourth power to 9, and I'm getting 6,561 for 9 to the 4th. Now here, I have power of a power. I have to multiply. 3 and 4 is 12, and n to the 4th. So my answer to number 11 would be 6,561 m to the 12th, n to the 4th. And the final question here, number 12, I have 5. I'm multiplying by, do you notice the power of a product? I have to apply the fourth power to the 5, and I also have to apply the fourth power to the x squared. So I have 5 to the 5th power, because this is over here, do you notice? I have the product of powers. I got to add my exponents. I got the same base. 5 to the 5th. Over here, power of a power, I multiply, x to the 8th. And I ought to simplify this. I don't want to keep it as 5 to the 5th. So I'm putting 5 to the 5th in my calculator, and when I do that, I am getting, error, let me do it again. I'm getting 3,125, and then x to the 8th, okay? I'm going to pause my video there. If you have questions, make sure you ask in class.